All right, so this is the third and final video for section 4.1, and it's just example 5, which is the word problem. Okay, so it says the estimated number V in thousands of electric vehicles, and more in thousands, in the United States can be modeled by the polynomial function, and then we get this big long equation, where t represents the year with t equals 1 corresponding to 2000. So use a graphing calculator to graph the function for the interval 1 is less than or equal to t, which is less than or equal to 10. Describe the behavior of the graph on this interval. All right, so if we go to our graphing calculator and I put my equation in the y equals and I hit graph, you get something that looks like this. It looks like a line, but we know this is not a line. We know it's a cubic function. But because we're so zoomed in on the the solutions, it doesn't give us the full picture, okay? So if you're not getting that, I am in Zoom Standard, okay? So go to Zoom Standard, and you should get that window, okay? But we want to restrict our t, which is our x, to between 1 and 10. So right now our x minimum's at -10, so we're going to restrict it into 1, and we're going to make the max 10. Okay, now we're going to graph this and it's still not going to look any better. Okay, the only difference now is we're between 1 and 10 and we don't see anything. So what I want to do is I want to make my calculator go into like where all the action's happening. So if I go here to zoom again, and I go to, let me find it, zoom fit. Okay, that's going to show me where all the action is. So I'm going to go to zoom fit and hit enter, and there's my graph. Okay, so if I go back to my notes here, I can see that the graph does something like where it goes up and then it kind of levels off and then it starts to go up again. Okay, so describe the behavior of the graph. So I would say we go up, then level off, then start to go up again. And once again, that's all in your graphing calculator. Okay, so here it says, what is the average rate of change in the number of electric vehicles in use from 2001 to 2010? So anytime we hear of the word average rate of change, we should be thinking of slope. Okay, and when we think of slope, to calculate the slope, we need 2 points. Okay, so we want to find out the point at 2001 and the slope at the point at 2010. Okay, so in 2001, we know that our t value is going to be 1, and in 2010, we know our t value is going to be 10. Okay, so now all I have to do is find the y coordinates, and I'm just going to go back to my calculator for that. Okay, now I'm back to my calculator, and this was our graph. So if I hit the second graph button to bring up the table, this is what I want. Okay, so second table. So you see when my x is 1 or my t is 1, my y is at 18.584. So I'm just going to 18.584. Okay, and then back to my graph, and I want to check what it is when my t is 10 or my x is 10. So I'm just going to scroll down, and I see 10 is 58.57. So I'm going to come back to here and I'm going to write 58.57. Okay, now we know that our slope formula is y2 minus y1 over x2 minus x1. Okay, so if I just subtract my y, so I can say 58.57 over minus, 18.584 over 10 minus 1. And I put that in my calculator, I get roughly 4.443. And remember, this is in thousands, okay? So really, we could move this over here if we wanted to. And so to interpret that, basically what that means is that the average rate of change from 2001 to 2010 is that we're adding about, I'm just going to put 4,400. You can put 44, 43, whatever. 4,400 electric vehicles per year. Okay, now if I look at C, it says, do you think this model can be used for years before 2001 or after 2010? Now, this one's not too bad, because before 2001, that would mean my t-value would be 0. Let's just say in 2000. Okay, my t-value would be 0, and if I plug 0 into this equation, I would get a negative number. So not before 2001, because we can't have a negative number of electric cars. Okay, well then after 2001, guys, this is a cubic function, so if I were to finish this, we would do this. And we would keep going to infinity. So after 2010, the graph rapidly goes up to infinity. So that probably wouldn't make much sense. Not it probably wouldn't, it wouldn't. Okay, now maybe it would be accurate for a few more years, but surely not for the long haul.